Okay, so this video is going to be introduction to probability. So basically, probability is the ratio comparing what you want to happen to the total number of possible outcomes. So number of favorable outcomes divided by the total number of total possible outcomes, or what you want to happen over the things that might happen. Please note, probabilities will range from 0 to 1. In other words, you'll never have a probability that's negative, and you should never have a probability greater than 1. If you do, you made a mistake. So it can be as low as 0 or as high as 1 and anything in between. The probability of 0, if you get that, it means it's never going to happen. There's no chance of it occurring. We generally don't talk about that because we generally like to talk about things that might happen or could happen or will happen. If it's guaranteed to happen, in other words, it's for sure, the probability is going to be 1 or 100%. And I don't mind whether you express probabilities as a fraction or as a decimal or as a percent. And you're probably going to want to use some combination of all of the above. So we're going to work on some basic probabilities just as a review from what you've probably had before in school and move on from there. So it says a fair number cube is rolled. The cube is six-sided. When they say a fair number cube, they mean a fair six-sided dice. And I'm just going to tell you really quickly that whenever you do problems in probability, it really helps to make a sample space, and it can be really simple. So when I roll a dice, I can either get a 1, a 2, a 3, a 4, a 5, or 6. That's all my possibilities, and your possibilities are known as a sample space. So my sample space is 1, 2, 3, 4, 5, or 6. And it says, what is the probability of rolling a 3 and a 6 on the second roll? So basically, I'm rolling the dice twice, and as such, I'm going to make 2 spaces. Well, when I look at this, there's only 1 3 out of 1, 2, 3, 4, 5, 6. So the probability of getting a 3 is 1 out of 6. And then it says a 6. Well, there's only 1 6. So the probability of getting a 6 is also 1 out of 6. Now, in this case, I know I can multiply because there's no impact from one roll to the other. In other words, they're independent. And we'll talk more about independence later. But as long as the first doesn't impact the second, we can multiply. The next thing says, what's the probability of rolling 3 2s in a row? Well, here I have 3 things that I'm doing, so I need 3 spaces. And by the way, making these spaces not required, but it certainly will help you out. It tends to help people not forget things. Well, when I look back at my sample space, once again, I only have 1 2 out of 6 numbers. So this is going to be 1 6, 1 6, and 1 6. And like we said before, one roll does not impact the other. So you could have expressed this as 1 6 to the 3rd power. And in this case, we end up getting 1 out of 216. Okay? So what's the probability of rolling a 5 on the first and either a 1 or a 2 on the second? So I'm going to take a moment and talk about a couple things. The word and, this is not a guarantee, but the word and usually means multiply. And the word or typically means in probability that we're going to add. All right? So what's the probability of rolling a 5 on the first and either a 1 or a 2? So we have a blank for the 5, we have a blank for the 1, and we have a blank for the 2. Now, we know the 1 or the 2 is going to have a plus. This is just a good mathematical principle. Anytime you have a plus sign, make sure you put parentheses around it. It'll get rid of a lot of errors, especially on the calculator. So once again, the probability of rolling a 5. Well, there's only 1, so it's 1 out of 6. We have an and after that, so that means multiply. And then a 1, and there's only 1 out of 6. And so there we have the way we'd set it up, and this works out to be 1 out of 36. And by the way, This right here is work shown. You don't have to show me the 1 over 36. If you want to go straight to the answer, you could have just gone, okay, 1 divided by 36, and you're like, oh, 0.0277. And if you would have done something like this, I would have been very happy with that, okay? All right, so what is the probability of rolling a 3 or 4 on the first roll and then rolling 2 6s? So we have a 3 or 4. This tells me right there I'm going to have an addition sign between the two blanks for the 3 or the 4. And like I said, anytime you have the addition, please put parentheses around it. Then we have an and tells me I'm multiplying, and then rolling 2 6s. So I got to roll 2 6s, and these are going to have a multiplication. Once again, our we can get a 1, 2, 3, 4, 5, or 6. The probability of a 3 is 1 out of 6. The probability of a 4 is 1 out of 6. The probability of a 6 is 1 out of 6. And then, just like we just said, 1 out of 6. This simplifies to 1 over 108. And if you just wanted to plug that into the calculator and go straight to the decimal, that's fine. Please remember, this is what I need to see for work shown. A fair coin is tossed. In other words, just a heads or tails. So what's the probability of tossing a coin, tossing a tail, and then a tail? So basically, our sample space for a coin is simply a heads or tails. That's what we can get. So we're going to do a tail, then a tail. So that means we need 2 of them. Well, that's 1 1/2 and 1/2. And this equals 1/4. All right. What's the probability of tossing 5 tails in a row? All right. Probability of tossing 5 tails in a row. That means I need 5 blanks. And I start going 1/2 times 1/2. And by the time I get to the second one, I usually get pretty smart and go, you know what? I probably don't have to write all of these 1/2s. I could have just said 1/2 to the 5th power. And if that's the work that if I had done that, this right here would have satisfied as full credit. So would this. So either one of those will get me full credit as far as work shown. And this is going to be 1 over 32. All right. And once again, if you wanted to go straight to the decimal here, that's fine. So independent events. We're not going to spend a whole lot of time defining independent, but basically independent says one event does not impact the other. So a fair number cube does not affect flipping a coin. So we have a fair number cube, which means we can get a 1, 2, 3, 4, 5, or 6. There's my sample space for that. And we have a fair coin, which can get me a heads or tails. So that's my sample space for that. What is the probability of rolling a 3 and getting a tails? So I'm doing 2 things, a 3 and a tails. So that means I need 2 spaces. They're separated by an and means multiply, or usually does. So 3 is going to be 1 out of 6. And the tails is 1/2. So this should get me 1/12 is my answer. All right, the next one. What is the probability of rolling 2 4s in a row followed by tossing 2 heads? So we have 2 4s and 2 heads. That means I need 4 blanks. And by the way, your scores will go up so much if you'll use the blank method. You really need to. I'm not going to sit there and go, hey, did they draw the blanks or not? But I'm telling you, you will do much better if you do. So a 4. The probability of a 4 is 1 out of 6. But I need another one, so this is 1 out of 6. And this is, I need 2 heads, and the probability of a head is 1/2. And they didn't say and or in here, but I need a 4 and a 4 and a 2 and a 2. And even though they didn't say the word and, I know that I need this and I need that and I need that and I need this because I need a 4 and a 4 and a 2 and a 2. So it's okay, A implied that I need to multiply. All right? And when I do that, I have 1 over 144. So what is the probability of rolling a 5 or a 6 and then tossing 3 heads? All right, 5 or 6 and tossing 3 heads. So that means I need that 5 or 6, and remember, or means add. And anytime we have an addition, we put parentheses around it. Then tossing 3 heads, 1, 2, 3. And our sample space is again 1, 2, 3, 4, 5, 6, heads, tails. The probability of a 5 is 1 out of 6. The probability of a 6 is 1 out of 6. And the probability of a heads is 1/2, and I need 3 of them. And when I multiply all of that out, it reduces to 1 over 24. And once again, if I'd shown this and then went to a decimal, that would have been full credit answer. All right, so we have a bag that has 3 A's and 5 B's. So this sample space is going to look a little different. We're going to have A, and then we're going to have B, 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 B. So right there I have my 3 A's and my 5 B's. What's the probability of drawing an A and rolling a 6 and tossing a tail? So I'm also going to have a 1, 2, 3, 4, 5, 6, and a heads and a tails. So what's the probability of drawing an A? Well, there's 3 out of 1, 2, 3, 4, 5, 6, 7, 8. So a letter, a number, and a tails. So 3 out of 8 for the A. Rolling a 6, this is going to be 1 out of 6. And tossing a tail, which is 1/2. All right, so this should have been a 1 over 2. And if I go ahead and multiply all of that, I get 1 over 32. What's the probability of drawing a B and getting a heads and either a 2 or a 3? Once again, we put in that or, that means add. Whenever we add, we need to put that in parentheses. When we're here, we have an and, so we know we're multiplying here. So the probability of getting a B, well, there are 5 B's out of the 8 letters. Getting a heads, well, that's 1/2. And then either a 2 or a 3. Well, there's 1 2 out of 6 and 1 3, so 1/6. And all of that would reduce to a fraction of 5 over 48. Okay? Moving on to the next one. All right, so here we have what are known as dependent events. Well, this is actually a little bit tricky. Yes, one event impacts the other, but you're going to watch what happens and see that we can still multiply under certain conditions, and we'll see what happens here. So a bag contains 3 A's and 5 B's. So we have A, B, 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 B. What's the probability of drawing 2 A's at the same time? So first off, we know we need 2 blanks. Now, this thing at the same time, that's tricky. We really don't want to picture it that way. What we want to picture is we drew 1 A and then we did not replace it, so we didn't put it back and we drew a second. So again, I'm going to say that at the same time means we drew an A, we didn't put it back, and then we drew another A. So what's the probability of drawing that? Well, the probability of the first A is really easy. It's 1, 2, 3 out of 8, so the first one is 3 out of 8. But I drew an A and I didn't put it back. So now, because I didn't put it back, I only have 2 left. And the total number changed. I have 1, 2, 3, 4, 5, 6, 7. So 2 out of 7. So 3/8 times 2/7. And we multiply that out, and it ends up getting 3 out of 28. This right here, again, is work shown, and if you went straight to a decimal, that's fine. What is the probability of drawing a B on the first and then drawing an A without replacement? So we're going to go back, and I'm going to recreate this. All right. So we're drawing 2 draws. We're making 2 draws, and we're doing it without replacement. So the probability of drawing a B on the first one is 1, 2, 3, 4, 5 out of 8. But now that's gone. And we're about to draw an A. Well, there's still 3 A's there, but look, there's 1, 2, 3, 4, 5, 6, 7 letters, so this is 3 out of 7. And this ends up giving me 15 out of 56. Going back, what's the probability of drawing 3 A's in a row without replacement? So we have A, B, 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 B. Well, we're drawing 3, so we need 3 blanks. The first one's pretty easy because we have 3 and we have 8 letters. But now that one is gone because we drew it. So we only have 2, and we need to be careful here. And we have 1, 2, 3, 4, 5, 6, 7 letters. All right. But now that one's gone, and I draw, it's like, oh gosh, I only have 1 A left. And I have 1, 2, 3, 4, 5, 6 letters. And that right there would be work shown. And if you went straight to decimal, that's fine. But this is basically 1 over 56. What is the probability of drawing 2 A's in a row and then drawing a B without replacement? So once again, we're still working with A, B, 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 B. 2 A's in a row, so 1, 2, and then a B. So there's my 2 A's and there's my B. The probability of that first A, 3 out of 8. But now we drew that. We only have 2 A's left. And be careful, we have 1, 2, 3, 4, 5, 6 sevens. Now that's gone. And we're going to draw a B. And it's like, well, gosh, we have all of our B's. We have 5 of them. But we only have 1, 2, 3, 4, 5, 6 letters. So 5, 6. When we multiply all that out, we end up getting 5 over 56. What's the probability of drawing an A, replacing the letter, and then drawing a B? So A, B, 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 B. So we're going to do 2 things. We're going to draw an A and a B. The probability of getting an A is 3 out of 8. But I put it back, so I still have all 8 letters, 5 of which are B's. So I have 15 over 64. Finally, what's the probability of drawing a B, replacing the letter, and then drawing an A? Probability of drawing a B, replacing a letter, and drawing an A. Well, once again, we're doing 2. And the B is 5 out of 8. I put it back, so I still have all 8 letters. And of those 8, 3 are A's. So it turns out that E and F have exactly the same number, the same answer. Okay, so moving on. The next video will be on basic probability, but I'm going to stop this one right here because that's long enough for an intro.